to all more virtual learning.
Okay, so good day everyone. Our lesson for today is about inequalities in one triangle, textbook pages 324 until 331. The objective of this lesson is to use inequalities involving angles and sides of triangles. In this lesson, we need to recall the concept we learned from the past lesson about exterior angles of a triangle. In this figure, angle 1 is the exterior angle since it is an angle formed by the extension of one side of that triangle. And angle 2 and angle 3 are its remote interior angles since these are the angles that are not adjacent to the exterior angle. So triangle exterior angle theorem states that the measure of the exterior angle is equal to the sum of its remote interior angles. So in this case, we have the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. So let's take a look at this example. So the exterior angle in this figure is 120 degrees. So 120 degrees is equal to the sum of its remote interior angles, which are 80 degree and 40 degrees angle. So therefore, 120 degrees is equal to 80 plus 40. So from the triangle exterior angle theorem, a corollary is made. So corollary to the exterior angle theorem states that the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. So if angle 1 is an exterior angle, therefore we can say that the measure of angle 1 is greater than the measure of angle 2, and it is also greater than the measure of angle 3. So let us now discuss problem 1.
In this problem, you will apply the corollary to the exterior angle theorem. Use the figure at the right. Why is the measure of angle 2 greater than the measure of angle 3? Remember, the corollary to the exterior angle theorem states that the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. How do you identify an exterior angle? An exterior angle must be formed by the extension of a side of the triangle. Here, angle 1 is an exterior angle of triangle ABD, but angle 2 is not. Angle 1 is an exterior angle of triangle ABD. Angle 3 and angle 4 are remote interior angles. By the corollary to the exterior angle theorem, the measure of angle 1 is greater than both the measure of angle 3 and the measure of angle 4. Segment BC is congruent to segment DC, so opposite angles are congruent. The measure of angle 1 is equal to the measure of angle 2. Substitute angle 2 for angle 1. So, the measure of angle 2 is greater than the measure of angle 3.
So let us now answer got it 1. So why is the measure of angle 5 greater than the measure of angle C? First, locate where is angle 5 and where is angle C. Now look at the figure. As you can see, angle 5 is the exterior angle of the triangle ADC. Therefore, angle 5 is greater than the measure of any of its remote angles that are angle C and angle 3. So therefore, by the corollary to the triangle exterior angle theorem, the measure of angle 5 is greater than the measure of angle C. Now let's have the second theorem. Theorem 5-10, which states that if two sides of a triangle are not congruent, then the larger angle lies opposite to the longer side. In this case, since xz is greater than xy, Therefore, we can say that the angle opposite to side XZ is greater than the angle that lies opposite to side XY. Therefore, we can say that the measure of angle Y is greater than the measure of angle Z. So let's have problem 2. A town park is triangular. A landscape architect wants to place a bench at the corner with the largest angle. Which two streets form the corner with the largest angle? So we are just given the sides of this triangle. 175 yards, MLK Boulevard is 105 yards, and Valley Road is 120 yards. So in order to know where is the largest angle, we need to see the longest side. So in this figure, Hollingsworth Road is the longest side, therefore the angle opposite to this road is the largest angle. So what are the two streets that forms the corner of this largest angle? It will be the MLK Boulevard and the Valley Road. Okay, so let's answer got it too. Suppose the landscape architect wants to place a drinking fountain at a corner with the second largest angle. Which two streets form the corner with the second largest angle? So based on the figure, we can see that 120 degrees is the second longest side. Therefore, the second largest angle will be the angle opposite to this side. So, which two streets form the second largest angle? It will be Hollingsworth Road and MLK Boulevard. Okay, so the converse of theorem 5-10 is 5-11. It states that if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. In this case, the measure of angle A is greater than the measure of angle B. Therefore, side opposite to the bigger angle A is longer compared to the side opposite to the smaller angle B. Therefore, as a conclusion, we can say that BC is greater than AC. Now let's have this video for Got It 3.
In this problem, you will use the theorem 511. Which choice shows the sides of triangle TUV in order from shortest to longest? Your choices are A. Segment TV, segment UV, segment UT. B. Segment UT, segment UV, segment TV. C. Segment UV, segment UT, segment TV. Or D. Segment TV, segment UT, segment UV. How do you use the angle measures to order the side lengths? List the angle measures in order from smallest to largest. Then replace the measures of each angle with the length of the side opposite. Remember that the triangle angle sum theorem states that the sum of the measures of the angles of a triangle is 180 degrees. The degree measure of angle U, 58, plus the degree measure of angle V, 62, plus the degree measure of angle T equals 180. Add 58 plus 62. Subtract 120 from each side of the equation. By the triangle angle sum theorem, the degree measure of angle T equals 60. Substitute the correct angle name for each measure. Use theorem 511 to substitute the opposite side for each angle. Segment TV is opposite angle U. Segment UV is opposite angle T. Segment UT is opposite angle V. By theorem 511, the length of segment TV is less than the length of segment UV, which is less than the length of segment UT. Choice A is correct.
Okay, so let's have got it 3. In the figure at the right, the measure of angle S is equal to 24 and the measure of angle O equals 130. Which side of triangle SOX is the shortest side? Explain your reasoning. So here it is given that the measure of angle S is 24 and the measure of angle O is 130. First, we need to find what is the measure of angle X. So since the sum of the measure of a triangle, the angles in a triangle is 180, therefore the measure of angle X is 26 degrees. And now, based on the measurement of the 3 angles of a triangle, we can now compare the length of its sides. So this is the smallest angle is angle S, which is 24 degrees, meaning to say the side opposite to angle S is the shortest side. Okay, so let us now have the theorem 5-12, which is the triangle inequality theorem. The triangle inequality theorem states that the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. So in this case, if you will add any of the 2 sides, it must be greater than the length of the third side. So xy plus yz must be greater than xz, yz plus xz must be greater than xy, and xz plus xy is greater than yz. So let's have problem 4. Can a triangle have sides with a given length? Explain. Okay, so the first question is a triangle with the sides 3 feet, 7 feet, and 8 feet. So let's apply the triangle inequality theorem for the first one. 3 plus 7 is greater than 8. 10 is greater than 8. So it is true. The second pair of sides, 7 plus 8 is greater than 3. So 15 is greater than 3, which is also true. The last one, 8 plus 3 is greater than 7. So 11 is greater than 7. Since the triangle inequality theorem is satisfied, so therefore we can say that it is a yes. The sum of the lengths of any 2 sides is greater than the length of the third side. Okay, so what about example B? 5 feet, 10 feet, and 15 feet. So add the 2 sides and compare it to the third side. So 5 plus 10 is not greater than 15. So it is a no. The sum of 5 and 10 is not greater than 15, and it contradicts the theorem 5-12. So got it 4. Can a triangle have sides with a given length? Explain. So the first one, 2 meters, 6 meters, and 9 meters. So let's apply the triangle inequality theorem. 2 plus 6 is greater than 9. So 2 plus 6 equals 8. It is less than 9. So therefore, it is a no, since a triangle cannot be made since the sum of 2 sides is less than the third side. Okay, so let's have example B. 4 yards, 6 yards, and 9 yards. So let's add any of the 2 sides and compare it with the remaining third side. So 4 plus 6 equals 10. It is greater than 9. 4 plus 9, it is 13. It is greater than 6. And 6 plus 9, it's 15. It's greater than 4. So yes, the sum of the lengths of any of the 2 sides is greater than the third side. Okay, so let us have problem 5.
In this problem, you will find possible side lengths of a triangle. In the solve it problem, you explored the possible dimensions of a triangular sandbox. 2 of the sides of the sandbox at the right are 5 feet and 8 feet long. What is the range of possible lengths for the third side? What do you know? You know the lengths of 2 sides of the triangle, 5 feet and 8 feet. What do you need? You need to find the range of possible lengths of the third side. What's your plan? Use the triangle inequality theorem to write 3 inequalities. Use the solutions of the inequalities to determine the greatest and least possible lengths. Let x represent the length of the third side. Use the triangle inequality theorem to write 3 inequalities. Then solve each inequality for x. One inequality you can write states that the sum of the length of the third side and the 5-foot long side is greater than the length of the 8-foot long side. Subtract 5 from each side to solve for x. X is greater than 3. Another inequality you can write states that the sum of the lengths of the third side and the 8-foot long side is greater than the length of the 5-foot long side. Subtract 8 from each side to solve for x. X is greater than negative 3. A third inequality you can write states that the sum of the lengths of the 5-foot long side and the 8-foot long side is greater than the length of the third side. 13 is greater than x. Numbers that satisfy x is greater than 3 and x is greater than negative 3 must be greater than 3. And x must be less than 13. So, the third side must be greater than 3 feet and less than 13 feet.
Okay, so let's answer got it 5. A triangle has side lengths of 4 inches and 7 inches. What is the range of possible lengths for the third side? So this is our triangle. This is 4, 7, and this is x. So we need to find the range or the possible lengths for the third side. So it must satisfy the triangle inequality theorem stating that the sum of any of the 2 sides of the triangle must be greater than the third side. So let's try first with 4 plus side x must be greater than 7. So we'll find the value of x. X must be greater than 3. Okay. Next, we will pair 7 and x. So 7 plus the side x must be greater than the third side, which is 4. So the value of x here must be greater than negative 3. Okay. The last one, these 2 sides compared to the third side, so that is 4 plus 7 should be greater than x. So 4 and 7 is 11. It should be greater than x. So what are the numbers that satisfies these inequalities? So x is greater than 3, x is greater than negative 3, and 11 must be greater than the x. So we cannot use this inequality since a side can never be negative. So here, the numbers that are greater than 3, so we need the numbers that are greater than 3, but less than 11. Why less than 11? Since the third inequality states that 11 is greater than any value of x. So meaning the possible lengths of this side x must come from numbers greater than 3 but less than 11. So It's this one. So I think you are now ready to answer your practice exercises and homework independently. Good luck!